Okay, welcome back. One check, over. Now, I've got a new one. The only difference here between this one and the last one is that there's no x squared term. That's the only thing I'm missing. So I'll show you what you do in this scenario. Other than that, the numbers are pretty nice, so this shouldn't be too difficult. So I'll try and do this one a little bit fast. I was trying to, I guess, be really slow. The other one. Okay, so x cubed minus x plus 4 divided by x minus 3. All right. So what I do first is I only really care about this x term here, right? So now I'm going to go, all right, how many times is x going to x cubed? Or would I have to multiply x by to get x cubed? Well, x squared. So this is where we run into a problem, because normally I'd say chuck it on top of the x squared term. There isn't an x squared term. So what you're going to do is you're going to force there to be one. So I'm just going to move these, extend this a little bit. I'm going to write plus 0x squared. So, and do this also if you were missing a term in here. Okay, so I've got my 0x squared term here. So now I'll ask myself the same question. How many times is x going to x cubed? It goes x squared times, and I'll write that on top. So now what I do is I go, all right, I want my remainder. So I need to multiply this by each of these terms. So x squared times x is x cubed, and I write it underneath the corresponding thing. And same deal, x squared times minus 3 is going to be minus 3x squared. And you'll notice that I wouldn't have had a space to write that if I didn't have this. If I'd written it here, then it might have been the case that when I got down the track, I would have brought this this positive 4 down before bringing this down. So it's really important that you include this 0 term, even though it seems counterintuitive. Okay, so now I perform my subtraction, so minus, and then I go, all right, that minus that is nothing. 0x squared minus 3x squared, so that's going to be positive 3x squared. And then I bring my next term down, minus x, which if I hadn't done them in order, I would have accidentally brought this down. Okay, next division. How many times is x going to 3x squared? Well, 3x, so plus 3x. I write it above my x term, and now I say to myself, all right, 3x times x is what? That's 3x squared, and then 3x times minus 3 is going to be minus 9x. I do my subtraction, and I write my subtraction line. 3x squared minus 3x squared is a nothing. Minus x minus 9x, or minus x plus 9x. That's going to be minus x plus 9x, that's 8x. And then I bring my next term down. And I'm almost done. I've exhausted all my options up top. So how many times does x go into 8x? Well, it goes in 8 times. How many left over? Well, 8 times x is 8x. 8 times minus 3 is minus 24. Now I subtract. 8x minus 8x, nothing. 4 minus, so plus 24. So 4 plus 24 is 28. And that's going to be my remainder. I hope, yes, I got that right. All right, so then in conclusion, I've got, I guess there's another way of writing this. The resultant, so this whole process equaled, what was it, x squared plus 3x plus 8, okay? I'm going to try and relate it to the last, oh my God, go in the middle. So think about this. We add this, right? This divided by this is equal to this remainder 2, or this and 2/65. So I'm going to write it like that. Okay, so it's this divided by this is this and 28 over x cubed minus x plus 4. It's just a different way of writing the same thing. That's my resultant, so that's what the division has produced. That's really disgusting, that line. Okay, but a different way of writing this is via okay. So the thing I started with equals my quotient times the thing I was dividing by plus my remainder. Now, I don't want to confuse people with this line. So what this was is the actual division. So what did that result yield? So that's the result, whereas this term on the bottom is just like another way of writing the thing I started with. So I hope there's you can differentiate between the two. Anyway, let's do one more. 4. That's my last question. All right, this one's worded a little bit differently. Should have written this before. Maybe skip forward 10 seconds. Okay, so this one says show that that is a factor of that. Now, I guess what you've got to think about is what makes something a factor of something. Well, if this question was show that 2 is a factor of 10, well, what would you do? You'd go, all right, well, I'm pretty sure 10 divided by 2 is equal to 5, and that's a whole number, so therefore this is a factor of this. So it's kind of the same thing. I'm going to do this divided by this, and I shouldn't end up with a remainder. If I don't end up with a remainder, then that's a factor of that. So like with this, if I did this division and I ended up with a remainder, then that wouldn't be a factor. It's kind of like saying, okay, show that 3 is a factor of 10. Well, 10 divided by 3 is something remainder something, that it's not a factor. So a factor is something without a remainder. So what I should end up with here is nothing. I should end up with 0. So that's the goal. So I'm showing that that's a factor of that. The way I'm going to do it is using long division, because obviously these two things are polynomials and I don't know any other way of... please don't be stupid. You can see me zooming. There we go. Okay, 2x cubed plus 5x squared minus 2x minus 30. Once you get this, you got it, eh? Divided by 2x plus 5. Okay, this one's a little bit different because I've got this 2x here. All right, so my terms are in order. I have all of them: x squared, x cubed, x squared, x to the power of 1, x to the power of 0, x. So I'm good. I don't have to add any 0 terms. So I can start. I only really care about this thing. I'm going to say how many times does 2x go into 2x cubed? Well, x squared. Verification, this times this is this. So it should be good. So what I'm going to do now is, so what I've said is, how many times does 2x go into this? It goes in that many times. What's my remainder? So I'm going to do this times each of these terms. So x squared times 2x is 2x cubed. X squared times 5 is 5x squared. Okay, this one's looking a bit funky. So now I'll make my subtraction. So this minus the same thing is nothing. And interesting thing here is 5x squared minus 5x squared is 0. Okay, so I've ended up with something a little bit weird here. And it's that I've ended up with nothing. But I haven't used all my terms yet. I haven't used these. So I bring them down. I bring him down, so minus 2x. And then I keep going. Actually, do I bring both of them down? Okay, sorry. I bring both of them down because my divisor has 2 terms, and I need what I'm dividing this by to also have 2 terms. So you're going to come down as well. Apologize, because normally what you do is you end up with a term. So like in this case, you end up with a term, and then you add a term on, so that this has two terms, and so does this. What I ended up with here is the fact that I've got nothing, so I needed two more terms, so I bring both of them down. What's the other way of thinking about that? When you're doing your normal division, let's suppose this was like, if it was too big, you'd have to bring more than one number down because there'd be not enough place values, if that kind of makes sense. I don't want to dwell too much on that, just there needs to be the same amount of terms on each side. Okay, so now I go, what am I doing? I've got my next step. I'm starting the next step. So what am I doing? Okay, so then I say, how many times does 2x go into this? So how many times does 2x go into negative 2x? So it goes in minus 1 time. Minus 1 time. I think I've done something wrong. Probably. Let's roll with it. Minus 2x plus 1. Okay, so then minus 1 times minus 2x is minus 2x, and then minus 1 times 5 is minus 5. Minus. Okay, so minus 2x minus 2x is nothing. Then minus 30 minus, so that's a plus. So minus 30 plus 5. All right, minus 30 plus 5, yep, is minus 25. And 2x plus 5 doesn't go into that. Oh my god. Textbook made a mistake. Okay, this isn't my fault. I thought I was being dumb. This is not my fault. The textbook has mixed up the question. Look at this. They've got a 2x here, and then here they've got a 12x. That's not my fault. I thought I was being so stupid then. Okay, we're good. So this was supposed to be a 1 that whole time, which meant that was that. So then I asked myself, that can go, this can go. Oh, we're good. This is recoverable. I was going to swear in this video, so then I had to delete it, but then we're good. Okay, so how many times does 2x go into minus 12? It goes in minus 6 times. Notice there's a gap here. That's because I skipped a place value here, and I'm putting it here. Okay, we're good. Okay, so then minus 6 times 2x is minus 12x. Minus 6 times 5 is minus 30. Boom. And 12. Okay, so, and then that's just 0. Okay, good. Now, are we done? Yes, I've shown it's a factor. Why? Because I don't have a remainder. So then I'd write just a conclusion. Therefore, 2x plus 5 is a factor of this. So there was a point like 2 minutes ago when I knew I was wrong because I knew I had this, like this was a 5 and I was going to end up with something here and I couldn't divide this into this. So that's how I knew I was wrong just then. But the only reason I knew that is because I know that this has to be a factor, so I knew the answer had to be 0. If I didn't know that, then I would have stuffed it up, but I blame the textbook. So, yeah. So that means I wonder how they get that last line. Oh, that's interesting. Interesting thing to note. Because there's no remainder, the way I can write my solution, so the 2x cubed plus, my next door neighbor's got McDonald's, I can solve it. minus 30 is equal to, so what I'm doing is this is equal to that times that. So that times x squared minus 6. Okay, and this is graphable because I can rewrite this. That's a difference of two squares. Might not be obvious what the squares are, but it's x minus root 6, x plus root 6. So if you'd actually, I'm going to go a step further. You can stop if you want, but I can go a little bit of a step further. This thing's a cubic, so if I were to draw this, let's solve this for 0. So x is equal to minus 5 on 2, x is equal to root 6, and x is equal to minus root 6. So x is equal to minus 5 on 2, what's that? Negative 2.5, that's there. Root 6 is, okay, so what is root 6? Root 6 is 2.5, 2.4. Okay, so there's a, what the hell? So they're right next to each other. The roots are right next to each other. Why would that be? That's minus 2.5, yeah? Minus 5 on 2. Okay, what on earth? This is minus 2.5, and this is, that is minus 2.4. Let me just double check that. Okay, so the roots are right next to, isn't that interesting? The roots are right next to each other. I wonder what this thing looks like. Oh, I really want to look it up. It's, okay, a couple of things I'm probably not going to teach you this year, but because this term's positive, it looks like this. So there's the possibility that this thing looks like that. I really want to graph it. I'm going to graph it. You can definitely stop at this point, but this is just for fun. Y equals. Come on. Okay. Does it just touch it? Can I zoom in? Okay, this is obviously a bit further. So that was 2.5. You can see, I don't know if you can see that. Can I enlarge it? You make me go pro, really? Okay. Judge for them. Judge we go. Okay, look at that. What can I zoom in? What can I click on anything? Wow, my screen's fully lagging. Okay, there we go. See how it just bounces above it at 2.5 and 2. That's what my graph looks like. So it does look like that. So it goes like this little thing, and then that. And then this turning point and that top turning point is what we use calculus for. Anyway, I took that way too far, but I think that's a bit of fun. So something like this definitely wouldn't be able to graph. Something like this can graph. So I think that's helps show why we do that in the first place, I guess. I think some people find that interesting. Actually, as a bit of extension, you could try and graph some of the ones that you end up being able to rewrite.